Now we're going to solve that same system of equations, but we're going to do it the linear algebra way. So we're going to take this exact same system of equations, and we're going to set them up first in the form A, V equals B. So remember, that's the fundamental problem we're trying to solve right now, is A times a vector V that's a vector of unknowns equals some given vector B. And we do that by plugging in the coefficients. So for the first equation, we have 1, negative 1, 1 are our coefficients. So we get 1, negative 1, 1. And remember that the v vector does determine the order. So we're going x, y, z. And then for the second equation, we have 2x and 1z. But you can imagine there's like a plus 0 y's out here, right? So there's no y's in the equation. And therefore, the second row is going to have a 0 in the y spot. So it's 2, 0, 1. And in case you were wondering, or you didn't know for some reason at this point, that's what you do whenever a variable is missing, is you just put in a 0 coefficient. And for the last one, we got to be careful. We can't put in 2, negative 1 into the matrix because the variables are out of order. So it's a 2y, negative 2z, and negative 1x. And since x comes first in our v vector, we need to put the x coefficient first. So it's negative 1, 2, negative 2. Then v has our x, y, z, and b is the solutions in the same order as the equations. So we have 4, 5, negative 6 for our b vector. So this is what we want to solve, but we don't really need to keep writing this middle chunk down over and over again. So the variables aren't going to change. We're still solving for x, y, and z. And usually in algebra you have to carry down an equal sign. Even that we're not going to carry down when solving this in this linear algebra way. So remember that linear algebra, we try to find shorthands for long lists of data and things, and this is kind of another shorthand for this equation. So we're going to take this and just write it like this. And this is the A matrix on the left, and then a bar, which is taking the place of our equal sign, and then the B. And for now, we don't really care what order we started with the variables. At the end, we will have to pay attention. If you started with a y and then an x and then a z, you would have to remember that at the end. But while we're doing this work, we don't need to pay attention to that. So here's all the numbers, and here's what we're trying to solve. So what did we do last time? We multiplied by negative 2, the first equation by negative 2, and then added it to the second equation to cancel out the x's. So we're going to multiply by negative 2, and what that does is multiply both sides of the first equation by negative 2. And this is what happens to the coefficients, is we had 1, negative 1, 1, 4 becomes negative 2, positive 2, negative 2, and negative 8. Next, we're going to add the first equation to the second equation, like we did last time. So last time we added the left-hand sides together and we added the right-hand sides together, and then you combine like terms, right? You combine the x's and the y's and the z's on the left. So if we were to add the first equation to the second, we would be adding minus 2x to 2x, and that would give us 0. We'd be adding 2y to 0y, which would give us 2y, and negative 2z to a z, which would give us negative 1z on the left-hand side. And then on the right-hand side, we'd be adding negative 8 and 5, which would leave us with negative 3. So instead of adding two equations together, we just add one row vector to another row vector. And it's the same thing algebraically. And now we don't want to we went back to the original equation that we started with, not this negative 2, 2, negative 2. We want to go back to 1, negative 1, 1, 4, and so we can cancel out the negative 2 just by dividing by negative 2, or multiplying by negative 1/2. So that'll cancel it out if we do that. On both sides of the equation, we have 1, negative 1, 1, and 4, and then we can use that one to cancel this third row, the original third row, which was minus 1, 2, minus 2, and negative 6, and we're going to add this to that. So 1x and negative 1x is 0, 2 and negative 1 is 1, negative 2 and 1 is negative 1, and negative 6 and 4 is negative 2. So we've eliminated the x's from the last two equations, and now we have two equations and two unknowns, if we ignore the first row. And now we're going to use the last two rows to solve the two equations and two unknowns. And let's see, so we're going to add negative 2 times the third row plus the second row, which is what we did above. And you can do this all in one step. You actually get pretty fast at it if you're taking a linear algebra course, because you'll be doing it fairly often. And then when you stop taking linear algebra, you lose the hang of going so quickly, but it's probably good to practice for now, because I'm assuming you're in a linear algebra class if you're watching. So let's take negative 2 times row 3. That would be 1 times negative 2 is negative 2, plus positive 2 gives us 0. So that's how this becomes a 0. And then negative 2 times negative 1 is positive 2. Positive 2 plus minus 1 is positive 1. So we get positive 1. And then negative 2 times negative 2 is positive 4. 4 plus minus 3 is just a positive 1. So we get positive 1. Okay, so now we have these two equations, and we've eliminated the y from the second equation. One thing we did not do above, because it's almost so trivial when you're doing algebra you don't even think about it, is we reordered the equation. Well, now we're going to reorder the equations. We didn't do it above because we weren't really paying attention to the order. But here we have a very clear order, right? This is row 1, this is row 2, this is row 3. And for purposes that will make more sense even in the next lesson, or for now you can think of as organizational purposes, we're going to swap these two rows. So it doesn't change anything about what the equations are saying. We're just saying that now this is our second equation and this is our third equation. And the reason we're doing that is we want to get 1s along the diagonal here, and we want to have 0s down here below. So this is our x, and we've canceled all the rest of the x's below it. This is our y, and we've canceled out the y's in the equations below that. And if we think about what this last equation means, right, if we actually write out all the equations, what have we got now? We're saying x minus y plus z equals 4. The next equation is saying y minus z equals minus 2. And the last one is just saying z equals 1. So we've solved for z. And we could just use back substitution here to figure out, if we put in z equals 1, we can find y, and then put in y and z, and we find x. But we don't have to come out of the matrix form to solve all this. So we do a similar thing by canceling the z's in the second equation. We just add the third row to the second row. So whenever we add 1 and negative 1, we get 0. And then whenever we add 1 to minus 2, we get negative 1. And we are adding actually all columns, but this is just 0 plus 0 and 1 plus 0. So 0 plus 0 is 0, 1 and 0 is 1. And now we've eliminated everything except for the y here. So the second equation has now become y equals negative 1. So we did use the z to solve for the y. It just looks different because we never came out of the matrix. And so finally we can add this row to that row. So we'll just add this, and then we'll subtract this row from this row. So what we'll have is 1 plus 0 minus 0 is still 1. We'll have minus 1 plus 1 minus 0 is 0. We'll have 1 plus 0 minus 1 is 0. And 4 plus negative 1 minus 1 is 2. So that 2 is coming from 4 plus whatever's in row 2, which happens to be negative 1, and then minus whatever in row 3, which happens to be 1, which is 4 minus 1 minus 1. And that leaves us 2. And now this the first row is just saying x equals 2. The second row is just y equals -1, and the third row is z equals 1, and that's all of our solutions. So we've solved the equations. And in review here, let me move myself off the screen. So we set up an augmented matrix, and then we could do 3 operations. We could multiply by a scalar, which is the same thing as taking an equation and multiplying by the same number on the left and right. We could add 2 rows together, which is the same as adding the left-hand sides of 2 of the equations and the right-hand sides of 2 of the equations together. And then we could swap rows, which is just like changing the order in which we've written down the equations. And we were able to reduce to, on the left-hand side, this diagonal of 1s on the diagonal only, and then 0s everywhere else. And then on the right-hand side, those were our answers, x, y, and z. Right, if I go up, the answers are 2, -1, and 1, so that's our solution. And this matrix over here with the 1s and 0s is important, and we're going to talk about it in the next lesson.